Hello to everyone, my name is Miroslav Kubelskiy, and today I'm going to talk about application of semantic networks and enterprise architecture approaches for creation of digital twins of organizations. I would like to sorry for quality of sound, but unfortunately I have no microphone, so I can't increase the quality. So, first of all, it is necessary to introduce key concepts of the research. The process of building digital twins is a part of the fourth industrial revolution or Industry 4.0. And the core process in the context of Industry 4.0 is the process of converting information into a digital format, that is, digitalization. And if we are talking about management practice, we can talk about digital transformation of enterprises. That is implementation of information technologies for supporting business activities. And in the context of Industry 4.0, enterprise can be considered as a system that is a combination of interacting elements organized to achieve one or more of the set goals. And this point of view is the part of systems approach to management, which considers enterprises as systems. Modeling is the main method for studying, analyzing, and predicting the behavior of any system. And this is also a part of systems approach to management. And the model is a simplified description of a system reflecting only those properties that are essential for modeling purposes. And building a digital twin is a process of modeling. So, what is a digital twin? According to ARCHIMATE and SAMET, Industry 4.0 consists of the following key technologies, such as cloud systems, augmented reality, smart factories, machine-to-machine communication, data mining, Internet of Things, enterprise resource planning and business intelligence, virtual manufacturing, intelligent robotics, and also cyber-physical systems. And digital twin is an example of cyber-physical systems, and it has many definitions, and one of them is using a digital copy of the physical system to perform real-time optimization. Another definition of digital twin is a dynamic visual representation of a physical object or system across its life cycle using real-time data to enable understanding, learning, and reasoning. Another definition, a digital twin is a digital replica of a living or non-living physical entity. By bridging the physical and the virtual world, data is transmitted seamlessly, allowing the virtual entity to exist simultaneously with the physical entity. And digital twin is a real mapping of all components in the product lifecycle using physical data, virtual data, and interaction data between them. The next question is, what is a digital twin of organization? As it was mentioned before, digital twin is a model. So there are too many objects of modeling. And if we are talking about digital twin, it is a rather mature technology. In literature and business practice, it is possible to find technologies and successful cases of modeling of such objects like products, technical systems like aircraft, or production processes. But what is a digital twin of organization? So, one of possible definition is the following. The digital twin of organization is digital twin that will be a living digital simulation model of the organization that updates and changes as the organization evolves. And upon becoming available, the digital twin will allow scenarios to be truly tested to predict the performance of potential tactics and strategies. Another possible definition is a digital twin of an organization is a set of information that allows to track a change in a company's situation when modeling various impacts on it: managerial, disturbing environmental influences, etc. For this, such a set of information should take into account all the essential causal relationships as well as contain the necessary and sufficient set of data to simulate the behavior of an enterprise in a market environment. As it was mentioned before, many types of physical objects can play a role of object for modeling. The construction of digital twin of organization, or DTO, is complicated by three main factors. The first one is that an enterprise is not a physical object with a constant structure, but it is a complex, dynamically changing socio-technical system that exists in the real world. Many of its elements and relationships between them are difficult for formal description, in contrast, for example, purely technical systems. And the problem is relevant to the field of enterprise architecture. The second problem that a significant part of concepts used in organizational management may not have clear definitions or have many different definitions, which also complicates the construction of formal enterprise models, which are necessary for building a digital twin of organization. So this problem belongs to the field of semantic technologies, namely ontologies and knowledge graphs. And the last one problem is that the data and information that should be integrated into the digital twin of organization have a different nature. It could be qualitative, quantitative, it can be multimedia, and so on. And this data has a heterogeneous structure, differ greatly in the degree of structuredness, and consists and stores in various, often unrelated sources. So this is a problem of integration, governance, and analysis of data and information. So, based on the following problem, it is possible to formulate a research gap, that the problem of creating digital twins of organizations is not covered enough in the literature, and there are no ready-made solutions that can fully realize the digital twin of organization technology. Now we can formulate research motivation and research goal. The main goal of the research is that, based on the synthesis of achievements in the field of enterprise architecture, knowledge engineering, especially semantic networks such as ontologies and knowledge graphs, and also based on data science, it is possible to overcome the mentioned problems and to develop a methodology for creation of digital twins of organizations. The main research motivation can be formulated as follows. The practical implementation of DTO technology, which has significant potential for application in the corporate and public sectors, can significantly increase the effectiveness of managerial decisions at all levels. And it is necessary to say that at the current stage, the presented research can be classified as research in progress, because the stage of practical implementation and testing of the methodology is the subject of further research. Therefore, the article presents the conception of the proposed methodology. Research methodology is based on design science research framework, which is widely applied in the field of enterprise architecture, business informatics, and information science research. Artifacts or instantiations are the main results of the research, of such kind of research. And according to Peppers et al., design science research includes 6 main steps. First of all, this is a problem identification and motivation, and we have already done this step. Define the objectives for a solution, design and development, demonstration, evaluation, and communication. Unfortunately, steps 4 and 5 are not in the focus of the current presentation, because this is a focus for the further research. To define the objectives for a solution, it is possible to formulate functional requirements and structural requirements for a technology. So, first of all, about functions. DTO technology should realize the following functions. Data modeling and mapping. We need to have an ability to compare digitalized data with the objects of the real world, which they relate, as well as modeling the data structure. Data acquisition, that is collection of various type of data, qualitative, quantitative, text, multimedia, and so on, from heterogeneous sources, as well as manual data entry, if they are not in the database of enterprise information systems. Data integration, that is integration of disparate data in a single space with a sufficient degree of their quality and purity. Data warehousing, and data analysis. So we need to have an opportunity to use various data analysis methods to search for significant dependencies, including visual analysis, as well as modeling methods such as simulation, factor, and predictive model. As for the structure, according to Tao et al., it is possible to identify 5 core elements of any type of digital twin. First of all, this is a real-world modeling object. In our case, this is a real-world enterprise. The second is a digital copy of the enterprise. The third one is the connection between the two. And the fourth is the data. Data is necessary for digital twin, and this technology should provide an opportunity for bidirectional flows of data. And the last one element is a service system, which can be considered as a user interface for interaction with a digital twin technology. So, the proposed methodology for creation of DTO is based on enterprise architecture. Enterprise architecture is an interdisciplinary field of research that allows for a holistic understanding of the structure of the enterprise, gaining particular relevance in the era of the fourth industrial revolution. So, the focus of enterprise architecture is the design, management, and transformation of a modern enterprise as a complex system that includes business and IT components. And enterprise architecture is based on the formal documentation of various aspects relevant to the enterprise, including corporate strategy, business activities, organizational structure, and information technology, application, data, and information architecture, with a special emphasis on the interaction and the interdependence of these elements. And in the field of enterprise architecture modeling language ARCHIMATE, which is the modeling standard within the TOGAF enterprise architecture management methodology, is frequently used. And as it will be shown later, this is a core element of the proposed methodology for building a DTO. And another basis for methodology for building DTO are semantic networks, such as ontologies and knowledge graphs. And knowledge graphs can be considered as a collection of objects, the attributes and type relationships between them. The connections between the objects The objects themselves and their attributes are defined in the models of the subject area, for which a knowledge graph is built, which are called ontologies. And the ontology can be defined as a formal explicit specification of the conceptualization of the subject area, which includes a hierarchy of concepts used in subject area, the types of relationships between them, and imposed restrictions. Ontology and knowledge graphs are semantic networks. That is, networks describing the logical or semantic relationships between objects of the subject area. In our case, the subject area is an enterprise. So, the ontology focuses on classes, attributes, and axioms. This is so-called T-box ontologies. And the instances of classes, A-box ontologies, are used in knowledge graphs. So, in order to move from ontology to knowledge graph, it is necessary to populate the ontology with instances. So, to build an organizational knowledge graph, we can reuse knowledge from enterprise architecture practice. For instance, we can use an ARCHIMATE modeling language, according to which any enterprise can be considered as a complex of 4 layers, such as business layer, data layer, application layer, and technology layer. If we are talking about enterprise goals or enterprise resources, it is a part of strategy elements, which is also a part of business layer. If we are talking about enterprise facilities and equipment, it can be considered as a physical elements, which are also a part of technology layer. We also, to build a DTO, we need to have an opportunity for modeling of attributes of the used concepts. It is possible to do like this way. We have concept A, concept B, and their attributes. We also have a relationship between these concepts, and this relationship also may have its own attributes. To demonstrate the approach, an architectural model was constructed for the fictitious situation of a manufacturing company. At the top of the figure are strategic elements, namely value flow and resources. The value stream consists of 2 stages, which are the first 2 stages of the product development or product life cycle: research and development phase and production phase. Each of which has 2 attributes: duration and total cost. For the implementation of each of these stages, a specific set of resources is required, including finance, special type of knowledge, and CAD software for R&D process, and physical resources such as equipment and material for the production phase. At the bottom of the model are elements related to all 3 architectural layers. To implement the first stage of the product life cycle, to implement a business process dedicated to R&D, in which the roles of a designer and marketer take part, belonging to specific actors, which certain knowledge and specific salary. This is attributes of these actors. An information system with a paid monthly license is used for design also. The result of this process is the design of the planned product, presented as a data object in a CAD model of the product. The second stage of the life cycle is implemented using another business process, production process, which receives the previously developed product design as an input. To implement this business process, 2 other employees are involved. As part of the business process, the technological process is being consisting of two sub-processes as manufacturing and assembly. Two units of equipment, 3D printer and CNC machinery, which require the previously obtained CAD model of the product as well as materials, plastic, metals, and electricity, each of which also has its own attributes such as price per unit and needed amount. At the output of this process, we have two separate parts, which are transformed into a ready product after assembly process. So, as a final result, we can get a real product, a ready product. So, if we have all these types of attributes for each element, we can do automatically calculations for the total costs of the product, for the total amount of knowledge that we need to perform these steps, and so on. So, using this architectural model with the main elements and with their attributes, we can perform a easy cost-benefit analysis, and we can evaluate our product from resources perspective. A system of adapters needs to be built between the enterprise and IT landscape and DTO to ensure continuous data acquisition. Adapters perform data parsing from enterprise information systems and convert them to the required form in accordance with the ontology, after which the data is written to the corresponding part of the knowledge graph. This process is illustrated in this figure, where the main types of enterprise elements are presented, and the main types of information systems that contain data relevant to these elements are identified. Data flows pass through adapters from information systems to the corresponding ontology objects. And in this picture, in this slide, you can see conceptual model of the methodology of digital twin of organization creation. So, what do we have here? First of all, we can consider 5 necessary structural elements of the DTO. We can consider real organization, connection between the two, data, service system, and virtual organization. A color codification has been introduced for each element and aspects of the methodology relevant to it. The main element of the DTO is the data that can exist in the organization both in digital form and non-digital form. The possibility to build an organization's DTO is highly dependent on what stage of the digital transformation it is at. The key point of the proposed methodology is to ensure interaction with the enterprise information systems, which ensures constant updating of the DTO. If the organization doesn't actively use information system, then for building a DTO, it will have to digitize the available data, which can significantly complicate the task of building DTO. A real organization can be presented as a set of collection of architectural layers, each of which includes certain types of objects, their attributes, and relationships between them. Digital data contained in enterprise information systems as a data object. Here it is on the picture, which are related to architectural data layer. A virtual organization includes an enterprise architectural model based on ARCHIMATE modeling language, in which prepared and transformed data are integrated. Changing this model, for instance, creating, deleting, changing the configuration of objects, attributes, relationships, allows to manage organizational ontology. The enterprise ontology serves as a description of the global scheme for knowledge graph, and it can play a role a global data structure of the enterprise. When the ontology is enriched with data, it transforms to knowledge graph, which performs the function of semantic integration of enterprise data. So adapters play a role of connection between the two elements, real organization and virtual organization, and they perform the data acquisition from enterprise information systems. Adapters perform parsing and transformation of the received data in accordance with the global data structure described by the enterprise ontology. So adapters are the part of service system, which also includes a graph database that performs the function of data warehousing, the structure of which is also determined by the ontology, and it is similar as global data structure of the organization. Interaction with the service system occurs through the user interface, which includes an architectural modeler, which allows the construction of architectural models and a description of real enterprise, as well as a data analysis model. The data which allows to apply various management decision support methods, including data visualization, machine learning methods, as well as various modeling methods such as imitation modeling, factor modeling, predictive modeling, and so on. So, looking at this scheme, we can identify 5 main structural elements, such as real organization, connection between two digital data, service system, and virtual organization. And we also can find our functions of DTO, such as data acquisition, data analysis, data warehousing, and data integration. So, conclusion. We can identify potential advantages of the presented methodology. For instance, the potential opportunity to build a DTO for almost any organization that has stepped into a digital transformation. A holistic view of the enterprise is provided with the help of an architectural model that can be easily changed and adapted during the organizational lifecycle. Implemented semantic data integration, opening up new possibilities for data analysis through the ability to take into account semantic relationships between different data. It reduces time and costs, increases the availability of data analysis and modeling methods by providing quick access to high quality and structured data, as well as through integrated decision support methods. The proposed methodology for building a DTO provides the ability to operate not only with data, but also with the knowledge of the enterprise. But a significant limitation of the presented research is the lack of practical testing and evaluation of the results of both the proposed methodology in particular and the entire technology of the DTO in general. So, further research involves the development of a service system that implements the methodology, as well as further testing of the proposed methodology. Thank you for watching this video.